B2A Solutions is your trusted IT consulting company located in the heart of Europe. We design, build, and maintain scalable and user-friendly solutions tailored to your needs. Want to join a team that is shaping the future of the JavaScript ecosystem in Belgium? A team involved in the community by organizing events and contributing to open source? Join B2A Solutions now.
Well, our next speaker is ready. I've been told he is a recovering gaming addict. How are you? Are you okay? Must have been hard.
Yeah, I could have done better.
Yeah, but you can stop at any time, you know?
So you say.
Yeah. Ujjwal Sharma is a compiler's hacker. So hacker is actually in your job title.
I mean, yeah.
You get paid to hack.
Yeah, I get paid, yeah.
At Ijalia and TC39, sorry, I don't know what TC39, you don't either.
I am,
Yeah,
for the most part. It's the committee that designs JavaScript, essentially.
Oh, okay. Yeah, who would have guessed?
Yeah.
He is an international speaker and very experienced on stage. He loves to talk about open source software decentralization. I had expected you, no, I will not give you free consultancy on in which cryptocurrency to invest, but that's still at home, I suppose.
Yeah.
I'm not. You're not in the market for free consultancy on.
But I'll talk about it.
Yeah, I will. Anyway, his talk today is about multicore JavaScript, past, present, and future. Let's hear it for Ujjwal Sharma.
Okay, yeah, thank you. Hello, and thank you for having me here. If you were inexplicably upset that Debbie was talking about actually useful stuff, then I'm your guy. I'm gonna yammer on for the next 30 minutes about impractical things. But like all of my work, it cannot begin before a ritual of self-congratulations. So hello, I'm Ujjwal. You can find me mostly everywhere with this weird-sounding username. So I'm Reisekooken on the internet. And for some reason, the slide, okay. Does that work? No. Okay. What? But anyway, so hello. As mentioned, I'm a compiler's hacker at Igalia. I am also a TC39 co-chair. So this means that if I say anything that's incorrect, you have to accept it as a fact. I am also the co-editor of ECMA 402. It's the specification about internationalization. I think Belgium would really appreciate a bit more internationalization and sort of localization into different languages. Also, in my previous life, I used to be a Node.js core collaborator, and I still am, but barely do much there. Also, I'm from New Delhi, India, and I live in A Coruña, Spain now. Also, I love dogs. Thank you. But that's all. One thing before I start, I wanted to point out is that most of the stuff that I talk about today is not things that I am working on directly myself, or at least alone. It's the collective effort of many awesome individuals. So, well, thanks everybody who worked on this, I guess. But yeah, before we begin, do any of you realize how ancient JavaScript is? And it's like, and we have a fairly young audience, and to sort of give you the contemporaries of JavaScript in the programming language area, I guess, all the hipster new languages are very new in this regard. So this was sort of the first few users of JavaScript, and JavaScript was conceived in, conceived is doing a lot of work there, but in December of 1995, and that was very long ago. Back then, CPUs used to kind of look like this. So this is the Intel Pentium Pro. It had one core, and yeah, if you like AMD, then that had one core too. But I wasn't around back then in 1995. The first computers that I was using was these, the Intel Celerons. I used to. That's where the addiction starts, right? They start early on. But today's computers are very different from computers back then, right? So, for example, a mobile processor, like the 8th Gen Snapdragon that you'd find in like most mobile phones, has 8 cores. And these are, of course, we can go deeper into what these cores are and why they're useful, or if they are at all. But and newer MacBooks also, for example, have up to 10 cores. So that's a very different kind of architecture that we're now writing applications in. And because of this, it's important that JavaScript scales to the hardware that JavaScript is running on, right? You should be able to use the hardware to its full capabilities. No, okay. Thank you. Let's talk about concurrency, and let's talk about how we approach this problem in JavaScript. JavaScript has 2 models of concurrency, not one. No, it's a beautiful language. There's the web-like model, which sort of works with run-to-completion systems like workers. So you have workers which you can spawn, and then they do stuff, I guess, and then they die. Or you have message passing between these workers. So you have things like post message, which you can use to make them talk, essentially. And you have things like async API. So promises where you can say, OK, hey, do this thing, and let me know when you're done. The best part about this model is that it has no room, for the most part, unless you're specifically writing code for it, to have things like data races, and there is some level of data isolation. So, for the most part, multiple promises that have been fired off would not like mess with each other, essentially. There is also the thread-like model, which deals mostly with synchronous APIs, which are running on different threads, and then you have to manually synchronize between them through things like atomics. This, however, gives you a lot of space to have things like data races. And there's also shared memory access. So you have shared array buffers in JavaScript, which kind of also set you up for data races. This is a very rudimentary diagram of how web-like looks. And, well, thread-like, on the other hand, have different threads of execution, right? With everybody sort of getting into shared memory. But JavaScript is a mess. But it's okay. It's our mess, right? What are the good things? So I was mentioning web-like is sort of my favorites. But what's good about it is that it is very easy to use it and to reason about it. This is why I think, because a lot of people who write JavaScript are not experts on concurrency. I guess why. It's nicer to use this. It's causal, so you can generally have some idea of how things are going to proceed. By construction, it's free from data races. Like, of course, you could construct code that would allow data races, but the general idea is that you wouldn't have them. There's also some level of isolation, as I mentioned. And asynchronous means that things are generally smoother and okay, whatever. Let's move to the next point. Also, it's less focused on manual synchronization mechanics. So you don't have to get down and manually synchronize every single call that's happening, every single access that's happening. And you don't need things like locks and queues and semaphores. If you don't know what they mean, thank you. Congratulate yourself. The bads, however, is obviously that leaves performance on the table. It doesn't allow you to sort of optimize the juice out of the computer, and that's not enough for most people. Well, not most people, but some people, definitely. Thread-like, on the other hand, one of the best parts about it is that it gives you WebAssembly interop. So if you are doing a lot of threading in WebAssembly, which is a thing now, you can play well with it using JavaScript if you do thread-like stuff. There's also explicitly interop with WASM-GC. So if you know, there's this new proposal in WebAssembly about garbage collection, and Thread-like is very good with that. There's also better performance if you can sort of unlock it. The bads, of course, is that it's very difficult to reason and use, which means, well, because you need to do manual synchronization, as I mentioned, and you have room for data races. There's also a causal astonishment. So there's situations where you see code and it behaves in a way that you wouldn't expect it to, right? It's happening out of order, and that's not fun. This all, like, sort of, all of these combined create a terrible, at least in my opinion, effect of must be this tall. I'll talk a little bit more about this, but and it exposes more timing channels. So if you're into security, if you want people to not split open your app and have some level of understanding about when things are happening because of timing channels, it's a bad thing. But yeah, so talking about must be this tall, this is an actual photo from the Mozilla office where, yeah, you must be this tall to write multi-thread code. And that's mostly because it's difficult and complicated. So TC39 has a problem, right? Should we focus on web-like, or should we focus more on the thread-like model and allow people to essentially write code using one of them, which we solved by doing both, because why not? So how do we approach this? Well, phase one is for web-like. This means language support for asynchronous communication. So you must allow async stuff, which, as you will see, we kind of do, right? And the ability to spawn units of computation. So you should be able to start computation in a different unit than what you have right now. On the thread-like side, you need some primitive to have shared memory, and some primitive for doing basic synchronization. Also, you need the ability to spawn threads. If you don't have threads, you are not going to be able to use threads, right? The fun part is that we're done here. If you realize with things like promises, async await for more high-level use of promises, workers, and shared array buffer for shared memory, and atomics for synchronization, we already have the tools to build concurrent applications in JavaScript. But it's still kind of not enough, right? So what do we have in store for phase two is for web-like, let's focus on ergonomic and performant data transfer. So right now, transferring data is not as fun, and it should be. And well, code transfer is virtually impossible. So we should also allow people to ergonomically and performantly transfer code. On the thread-like side, we need higher-level objects that allow you to concurrently access stuff without breaking everything. And we need higher-level synchronization mechanisms, because apparently nobody knows how to use atomics. Not even the people who designed it. So for phase two, as I mentioned, it's trying to address the biggest pain points that exist right now. Transferring data is expensive. If you transfer data, you know what I mean. The amount of transferables in the JavaScript language, things that you can pass around, is very limited. And objects which we use so much they can't be transferred because of this. Because of weird semantics around the reparenting of prototypes. So if you have two different JavaScript applications, you can't throw around objects on the boundary, which means that often, if you are transferring objects, you would either copy them or you would serialize them into a string. And all this sort of serialization and deserialization is very expensive. Transferring data is also unergonomic, as I mentioned, so it requires this big ritual of serialization and deserialization. And it also means that there's identity discontinuity. So if you have an object and you throw it to another application, get it back, you don't know it's the same object, but it's a different object now, I guess, which is also philosophical, but I don't think we care. Transferring code is basically not possible. We just transfer strings, and that's it. Like, you could throw that string of code into exec, but that's not as nice as you'd like it to be, right? So a proposal that we're working on is module blocks in order to fix that. So it aims to solve the problem that I just mentioned, the ergonomic sharing of code. It's spearheaded by Surma, who is really cool. But essentially, module blocks let you do this, right? So you could write modules previously, but now they don't have to be inside a file. You can write inline modules and assign them to variables, and then throw them around. And you can import them, you can throw them into workers, and now you can throw them into shadow realms. The possibilities are endless. There is an upcoming proposal, which is about shared disjoint heaps. So if that sounds weird, let me tell you what it means. It aims to solve the problem of well, all the problems, really. It's trying to solve the ergonomic and performant sharing of data and code, right? But how does this work? So it allows developers to separate their heap, right? Right now, you can write code and it's all going into the same heap, the same context. Everybody's writing code in. But now you can have disjoint heaps. So agent local heaps, which is where you're writing and running code in, can point into these sort of shared islands, and they can share them and pass them around. Shareable heaps cannot point into agent local heaps, of course, because those may come and go. But yeah, the transferable heap is sort of the unit of sharing, right? So you have, you take like a bundled up a bunch of code and you throw it around among different sort of agents or running environments, and they can all reuse it. And if there's data in there, they can reuse that as well. For thread-like on phase 2, well, not too hard to guess, but it's also designed to address the biggest pain points, at least what we thought were. So, as I mentioned, nobody knows how to use shared array buffer and atomics. Like, they are not being used at all. And the impedance mismatch is too high. So, as I mentioned, like I think I'm doing thread-like a favor when I say, oh, hey, this is so good for performance, and you can optimize it, because most of the time you don't know how to do that. So it's very complicated to reason about it and to do things in a way that is guaranteed to be faster. A proposal that we're working on also is structs. So don't lose your mind, but structures in JavaScript, right? It aims to solve the problem of higher-level objects that allow concurrent access, right? So if you have an object and you're trying to access it from many different threads, that's going to be a mess, because you're going to run into all sorts of problems. You don't know who's accessing it right now, who's modifying it, and structs try to solve that. So it's spearheaded by Shu, who's also awesome. But yeah, so this is how structs work. It's, well, at least how we hope they would work. You can start with a struct keyword in front of a class, and this means that, well, you can declare this new variable, but you cannot change the value, or you cannot change the prototype because they're sealed. And yeah, so this allows you to have something which is mostly similar to an object, but have some level of confidence that people are not going to do terrible things with it. And that's what we had for the most part. But what about a future phase? What are we looking at when we talk about this area of work? For web-like, maybe we could have lighter weight actors. If you've used workers, you might know that they're not so lightweight, which means that spawning each worker is a lot of work. And it takes a lot of time, and sometimes it's not worth it. Like, if you want to do very tiny things, you cannot keep spawning workers, which means you need things like worker pools and all this math. What if we had lighter weight actors? What if we had like micro threads or micro workers, which would quickly spawn, do the work, and disappear? We could also have better integration with scheduling APIs. So this is complicated because JavaScript doesn't have like a unified scheduling API. But I think with the way practically that most JavaScript environments work, there could be some level of abstraction that could be applied over all of them. So hopefully this would be useful for people who think that this model is not fast enough for them, and they could do interesting stuff with it. Also, maybe we could have a concurrent standard library. Maybe we could have a library that returns promises instead of, well, synchronously doing stuff. On the thread-like side, tooling is really important because, as I mentioned, nobody can do this apparently. So probably we could have better tools that assist people with writing their code and be more confident about their code. Better integration with WebAssembly, of course. I'm a big fan, so I keep putting it here. But yeah, maybe we could improve this further. Also, a concurrent standard library. So what if we had a standard library that worked better with threads? It's a tough choice because we cannot take the same choice that we took previously. We have only one standard library, which means that it would either have to be that or that, which is a difficult choice. There's proponents for both. But yeah, that's it. I want to quickly thank people. Thank you to the organizers for having me here. And thank you all for being patient.
B2A Solutions is your trusted IT consulting company located in the heart of Europe. We design, build, and maintain scalable and user-friendly solutions tailored to your needs. Want to join a team that is shaping the future of the JavaScript ecosystem in Belgium? A team involved in the community by organizing events and contributing to open source? Join B2A Solutions now.